Hello everyone, and welcome to another Mathematics and GIS tutorial video. And in this video, I want to sort of go back and talk a little bit more conceptually about this idea of point and polygon, hopefully clarify that whole concept of the bounding box, and really hammer home this idea of point of lines to the right of a point, and why if it's odd, it means it's inside the polygon, and why if it's even, it means it's outside of the polygon. So I'm going to go through a lot of examples. We're not necessarily going to do the math for calculating the points of intersection. Rather, what we're going to do is we're going to take the graphics, we're going to take the graphical representations here, and we're just going to walk through sort of what these things mean conceptually. Because hopefully at this point, after going through the intersecting lines tutorial videos and the previous point and polygon tutorials, you have a good foundation of how to figure out where lines intersect. But you might just be kind of struggling conceptually, wrapping your head around why we care about a bounding box and why there's this even odd thing dealing with points to the right of a line. Or sorry, lines to the right of a point. Okay, so the first thing we have here is we have this triangle, right? And we have this point here. And we want to know, well, is this point inside of this triangle? Visually, right, we're already going to say no. But what we have to do is we have to go back and we have to think about our two main questions, right? One, right? Oh, that is very large. Let me shrink that down a little bit. Right, one, is the point in the bounding box? You have to realize from a computational perspective, right, if all you had were coordinates and you didn't see this graph, right, checking the bounding box is a really fast way to just sort of throw out things that have no possible chance of ever being inside the polygon, right? But let's go ahead and let's use this as a chance to sort of solidify this concept of the bounding box. Okay. So when we said the bounding box, right, we said that it was the box made that would happen if you connected the x min, x max, y min, and y max of your polygon, right? And so what we can see here, right, this is our x min and our x max. This is our x min and our y min right here. This is our x max and our y max right here. Right, so if we were to draw a vertical line up from our y min to our y max along our x min, right? That's what this green, let's make that a little thicker. Right, that's what this line right here represents, right? This is the x min vertical line. And we were to do the same thing here, right? This is our y max horizontal line. Right? This is our x max vertical line, and this is our y min horizontal line. If the point was outside of this box, there'd be no way that it could ever intersect our polygon. Right? But this point is inside of that. So then we have to say, okay, well, how many so it is inside, so we can check that off. It is inside of our bounding box. So 2, we have to ask ourselves, okay, how many points are to the right, or I keep doing that. How many lines are to the right of our point? Okay. All right. And so what we did before, and we're going to do this again, right? We're going to take we're going to draw a horizontal line from our point. Make it a little bit bigger. We're going to draw a horizontal line from our point all the way over until we hit that x max vertical line, right? And we're going to say, well, how many, now we're going to convert that to how many lines intersect this line. And so the answer here, we have one intersection. Let's do this in gray. Right, we have one intersection here, and we have one intersection here. So our answer is 2. Right? 2 lines intersected that line. So again, right, even means the point is outside the polygon. Okay. So hopefully this solidified some of the concepts. We're going to go through another example because I really want you guys to understand conceptually what we're doing and why it works the way that it does. So let's go ahead and let's do 2 different points here. We have this green point here, and we have this red point here. So the first thing that we're going to do, right, step 1, are the points inside the bounding box. Okay, so again, what is our bounding box? Well, we're going to find the lowest x coordinate, which is this right here, and we're going to draw a nice vertical line. Let's make it a little thicker. We're going to draw our vertical line. This is our x min vertical line. We're going to find our lowest y coordinate, which in this case is this, and we're going to draw a horizontal line. And this is our y min horizontal. We're going to do the same thing for the highest x value and the highest y value. Okay. All right, so this orange rectangle, this is our bounding box. And so are these points inside of the bounding box? Yes, they are, which means that we would indeed have to continue. So let's look at the red point first. Right, so let's look at the red point first. So check. They are both inside of the bounding box. So 2. Right, we're going to ask ourselves how many lines are to the right of our point. So let's do the red point first. Right, so we're going to start here. We're going to draw a horizontal line until we reach our x max. Right. So we have this line here. So how many points, how many lines does this intersect? It intersects 1 right here. Right, so our red line intersects 1. So because it only intersects 1, right, because that's odd, right, odd means in. Let's go ahead and do our green point here, right? Again, same concept. We're going to draw a horizontal line from the point to the right until we hit our x max. Right? Now, how many lines does this intersect? Well, it intersects 1 right here. It intersects 1 right here. So that's 2. Right? 2. Which is even. Which is even. So even means out. Right? And so a way of sort of checking yourself here, right, is if it's not inside the bounding box, we don't even have to bother checking how many lines are to the right. But if we are inside the bounding box, we have to check. If it's even, it means you're not inside the polygon. Right here, it crosses one line and it crosses another. If it's odd, it means you're in. Right, this only crosses the one line. So hopefully this solidifies the concept of a bounding box, what it means conceptually. Hopefully going through a couple more complex shapes geometrically shows you why this odd means in and even means out concept. And again, if you have any questions, please reach out. Thank you.